This is an example problem for Kirchoff's rules, using Kirchoff's in solving electric circuits. So find the magnitude and direction of the current in the 2 ohm resistor in the drawing. So this is the 2 ohm resistor. Now let us solve this circuit using Kirchoff's. Okay, so we are required to get, let this be our given, the circuit. We are required to get I2, the current on the 2 ohm resistor. You are being asked to find the magnitude and direction of this current. Now let us apply Kirchoff's in this circuit. So let's try to solve. Okay, let us first so we are asked to find the current on this resistor. The current on this 2 ohm resistor. Now let us apply first Kirchoff's rules. Kirchoff's rules is also known as Kirchoff's current law or Kirchoff's voltage law, or it is the loop rule or the node rule. So let us apply Kirchoff's current law, KCL, or in some book this is node rule, KCL at a node. Let's say this is the node. Let's say this is node A, KCL at node A. So let us assign a current for these 3 resistors. So let's say that the current on this 2 ohm resistor is going in to the node A. So let's say this is current 2, I2, and from this node goes out the current going to I1, R1. Let's say this is I1, the current on the resistor 1, and also a current goes out of the node and flows through R3. So let's say this is your I3. So that is the first thing that you have to do, to assign the flow of the current. Now from this flow of current, let us assign a terminal poles for these resistors, the positive negative side, or the positive negative pole of this resistor. So let us just be consistent with our convention. Like for example, if we assign that from where the current goes in is positive and where the current goes out is negative, then let us be consistent to all the resistors. So like for example, from I2, let us assume that this is positive and this is negative. So dito pumasok and lumabas yung current sa negative. So let us be consistent for all the resistors. So for I1, pumasok dito, this is positive. So lumabas dito ay negative. And this is also positive, then dito ay negative. So again, we first assign the direction of the current. Actually, you don't have to be afraid to assign whatever direction, because later on, from the answer na makukuha ninyo, makikita nyo lang din naman if baliktad yung direction ng current na nai-assign ninyo. But what I would really suggest is that you just have to be consistent with your conventions. So like assigning these terminals. So just be consistent. Kung saan pumasok yung current, positive. Kung saan lumabas, negative. Ito, pasok, positive, labas, negative. Pasok, positive, lumabas, negative. Ikaw ang mag-a-assign na. We assume, okay? Now, so KCL at node A. According to Kirchoff's current law, current in is equal to current out, because this is current conservation. Kung ano yung pumasok na current, dapat yun din yung lumabas. So if we'll try to look at node A, so current in is equal to current out, I out. So the current that goes into the node is I2, and there are two currents that goes out, I1 and I3. So we'll have the equation I2 is equal to I1 plus I3. So let this be our equation number 1, because in Kirchoff's we will be now utilizing our knowledge in algebra, simultaneously solving equations in 2 or 3 variables. So later on, we'll use our knowledge in algebra in solving for this current. Now let us apply KBL now to the circuit, or the Kirchoff's voltage law. Now to apply KBL or Kirchoff's voltage law, we need again to assume a loop. When we say loop, it's a circular path for each loop, for each closed circuit, a closed connection in the circuit. So that is what we call a loop. So based from what we see in the circuit, we can have 2 loops. We can call this the upper loop as loop 1 and the lower loop be loop number 2. Now we have to assign the direction of this loop. So like for example, if we will assign a loop for the upper part of our circuit, let's say that this is the direction of my loop. Let's say this is loop 1. Okay, so that is loop 1. Now I will try to look at all the resistors and all the components na madadaanan ng loop na to. So like for example, in this circuit, tatlo ang madadaanan niya. The 1 ohm resistor, the 2 ohm resistors, and this voltage source. Now, so we need to look to the terminals kung saan lalabas ang loop na to. Like for example, if this loop ay lalabas sa resistor 1 going in this direction, then lalabas siya doon sa positive terminal side. Then sa 2 ohm resistor, lalabas uli siya pag ganun, lalabas uli siya sa positive terminal side. Pero dito sa source, lalabas siya sa negative terminal side. Now according to Kirchoff's voltage law, the sum of all the potential differences, it's either, may it be potential rise or potential drop, is equal to 0. So according to Kirchoff, the sum of all the potential rises plus potential drop is equal to 0. Therefore, by magnitude, okay, V rise is equal to V drop. Okay, so if we will apply KVL to the upper part of this circuit, to loop 1, again, be consistent. Saan lumabas ang loop? Dadaan dito sa resistor 1, lalabas siya sa positive. So, kung positive siya, then assume that that is a potential rise, V rise. So, the voltage on current 1, the voltage on resistor 1 is a voltage rise. So, we have V1 as voltage rise. Then we have the 2 ohm resistor. So again, following the loop, it will go out on the positive terminal side. Therefore, again, the 2 ohm resistor has a voltage rise plus V2. Then following again the loop, the source, if we will look at the source, the loop will go out to the negative terminal of the source. Therefore, this is potential drop. So we will have minus the source, which is 1 volt. So let us first disregard the units, equal to 0. So we will have our equation V1 plus V2 is equal to 1. Now from Ohm's law, we know that voltage is equal to IR. So we can rewrite this equation by I1 R1 plus I2 R2 is equal to 1. That now we can substitute the values of our resistor. For the current one, the resistor one is 1 ohm. So this will just become I1 times 1. R1 is 1. Now for resistor 2 is 2 ohm. So this is 2 times the current on the 2 ohm resistor is equal to 1. Now let this be our equation number 2. Okay, so we have equation number 1, then we have equation 2. Now let us continue applying KVL, by this time on the second loop. KVL at loop 2. Now we will again assume a loop on the lower part of our circuit. Now if I will assume a loop according to most books or references, we will assign another loop. Imagine niyo ang gear. So as much as possible, hindi siya magsasalungat. So if I will be assigning the direction of the loop for the lower part of this circuit, the direction should be on this direction. So para siyang gear, hindi siya, as much as possible, wag sumalungat doon sa loop mo on the upper part. So I will assign a direction, a clockwise direction for loop 2. For loop 1 is counter clockwise. Now again, let us apply KVL or Kirchoff's voltage law on loop 2. Now if we will follow this direction, the 1 volt source will become a potential drop because it will go out on the negative terminal. Then the 4 volts will also be potential drop because it will go out to the negative terminal. Then to the 3 ohm resistor, it will be potential rise, because it will follow this direction. It will go out to positive terminal, and for the 2 ohm resistor also, for the 2 ohm resistor, it will also be a potential rise. So the 2 resistors potential rises, then the 2 volt source is potential drops. So from our KVL, again applying that according to KVL, or Kirchoff's voltage law, voltage rise plus all the voltage drop is equal to 0. Now voltage rise is the voltage on the second resistor, V2 plus V3. Then we have the sources, which is potential drops, minus 1 volt minus 4 volts is equal to 0. Sorry, this is V3. So we will have an equation V2 plus V3 is equal to, transferring these numerical values, will have 5. Now again, from Ohm's law, this is I2 R2 plus I3 R3 equals 5. But resistor 2 is 2 ohms, so this is 2 I2. Then R3 is 3 ohms, this is 3 I3 is equal to 5. Now this is now our equation number 3. So we now have 3 equations for 3 unknowns. We have 3 unknowns, I1, I2, and I3. Let us have the 3 equations. From equation number 1, we have I2 is I1 plus I3. Okay, I2 is equal to I1 plus I3. Then our equation 2 is I1 plus 2I2 equals 1. I1 plus 2I2 equals 1. And from our equation number 3, we have 2I2 plus 3I3 equals 5. Now if we will remind ourselves of our knowledge in algebra, we need to solve for this equation simultaneously. Okay, solving equations, 3 equations, 3 unknowns. So actually class, ang goal lang naman dito is that you make a goal in your mind to find an equation wherein the variables are the same. So if we're, like for example, if we are looking for I2, then we should find an equation wherein dapat lahat sila I2. So by just observing this equation, so that I can really simplify the equation, if I would like to find I2, I have to express I1 and I3 in terms of I2, in which in this problem it is very practical that I1 can be expressed through I2 and I3, because from equation 2 we can have I1 is equal to 1 minus 2I2, and from equation number 3, I3 can also be expressed in terms of I2, in which I3 is equal to 5 minus 2i2 all over 3. So we have now I1 in terms of I2 and I3 in terms of I2. If we will substitute these two equations to our equation number 1, then all the variables for equation 1 will become I2. So you'll have I2 is equal to I1, which is 1 minus 2I2. Okay, so that is our I1, plus I3 equal to 5 minus 2I2 all over 3. So if you will notice, all the variables now on this equation is I2. Okay, so let us multiply both sides of the equation by 3 so we can eliminate the denominator 3 on this term. So it will become 3I2 times 3 times the quantity 1 minus 2I2 plus quantity 5 minus 2I2 all over 3. So this will become now 3 minus 6I2 plus, and this term 3 will be cancelled, 5 minus 2I2. So we'll now have 3I2 is equal to 3 plus 5 is 8. Negative 6I2 minus 2I2 is negative 8I2. Transferring negative 8I2 to the left side of the equation, we'll have 3I2 plus 8I2 is equal to 8. Now we'll have 3I2 plus 8I2 is 11I2 is equal to 8. Divide this by 11. Divide this also by 11. I2 is 8 over 11, or approximately 8 over 11 is approximately 0.73 amperes. Now since we get a positive answer for I2, then we can assume that our direction, the assumed direction, is correct. Kasi kung negative ang nakuha natin dito, then we just have to reverse the direction. So if we are to get the direction of this current, this is 0.73 amperes going to the left. Because according to our illustration, let us go back to our illustration, I2 is going to the left, going inside node A. Therefore, for I2, this assumption for the direction of current is correct, going to the left. So our answer for this problem is 0.73 amperes going to the left. Again, I would like to remind you that in solving circuits using Kirchoff's, you just have to be consistent with your conventions. Okay, for the assigning of the direction of the current, you just have to assume whatever direction, but you have to be consistent assigning the terminals of the resistors. Then for the loop, you can assume any direction at first, but for the next loop, as per the most of the resources of the books that we use, imagine a gear that the loop should not as much as possible contradict each other. Okay, so those are just simple tips of how to use Kirchoff's in solving electric circuits.